Welcome to data indexing and selection. Now, let's make a new file and save the file by the name data indexing and selection. So, in the last section, we looked in detail at methods and tools to access, set, and modify values in NumPy arrays. These included indexing. Let me give you some examples. Like this, these included indexing, slicing, masking, fancy indexing, and combinations thereof. So here we'll look at similar means of accessing and modifying values in Pandas series and data frame objects. If you have used the NumPy patterns, the corresponding patterns in Pandas will feel very familiar, though there are a few quirks to be aware of. So we'll start with the simplest case of the one-dimensional series object and then move on to the more complicated two-dimensional data frame object. So, starting off with the data selection in series. As we saw in the previous couple of lectures, a series object acts in many ways like a one-dimensional NumPy array, and in many ways like a standard Python dictionary. If we keep these two overlapping analogies in mind, it will help us to understand the patterns of data indexing and selection in these areas. So let's discuss our first point, which is series as dictionary. Like a dictionary, the series object provides a mapping from a collection of keys to a collection of values. Import pandas as pd data is equals to pd dot series 0.25, 0.5, 0.75, 1.0. Index is equals to A, B, sorry, I got this, B, G, and we got the output, this. Where we got the error, that was a full stop instead of a comma. So now data B, let's look at the data B. Oh. Data. So we can also use dictionary like Python expressions and methods to examine the keys, indices, and values. That's true. Data dot parentheses, we got this. List data dot items, we got this. So series objects can even be modified with a dictionary like syntax. So just as you can extend a dictionary by assigning to a new key, you can extend a series by assigning to a new index value. Data 1.25. We got this. This easy mutability of the objects is a convenient feature. Under the hood, Pandas is making decisions about memory layout and data copying that might need to take place. The user generally does not need to worry about these issues. So now let's discuss series as one-dimensional array. Series builds on this dictionary-like interface and provides array style item selection via the same basic mechanisms as NumPy arrays. That is slices, masking, and fancy indexing. Examples of these are as follows. So we have slicing by explicit index. A, C. We got this. So slicing by implicit index. We got this. And now let's try masking. Data, square bracket, bracket, data 0.3, and data 0.8. And now fancy indexing. Among these, slicing may be the source of the most confusion. Notice that when you are slicing with an explicit index, that is data is data A to C, the final index is included in the slice. While when you're slicing with an implicit index, that is implicit index, the final index is excluded from the slice. Okay, so now let's discuss indexers, IOC, ILOC, and IX. So these slicing and indexing conventions can be a source of confusion. For example, if your series has an explicit integer index and indexing operation, such as data1 will use the explicit indices, while a slicing operation like data1, 1/3 will use the implicit Python style index. Starting it off with data is equals to pd dot series A, B, C, index 135. Got this. Now explicit index when indexing. Now implicit index one. Got this. Because of this potential confusion in the case of integer indexes, Pandas provide some special indexer attributes that explicitly expose certain indexing schemes. These are not functional methods, but attributes that expose a particular slicing interface to data in the series. First, the LOC attribute allows indexing and slicing that always references the explicit index. LOC, we got A, now data dot. We got this. The ILOC attribute allows indexing and slicing that always references the implicit Python style index. Now a third indexing attribute, IX, is a hybrid of the two, and for series objects is equivalent to standard based indexing. The purpose of the IX indexer will become more apparent in the context of data frame objects, which we will discuss in a moment in the couple of lectures. So one guiding principle of Python code is that explicit is better than implicit. The explicit nature of LOC and ILOC makes them very useful in maintaining clean and readable code, especially in the case of integer indexes. I recommend using these both to make the code easier to read and understand and to prevent subtle bugs due to the mixed indexing or slicing convention.